red food coloring, which represents the ice on Mars in the ice cap. And we would use the pod to get the ice and then put it in this aluminum plate, which has a hot plate under it, which it would melt the ice and it would go all the way down to the aqueduct to the purifier.
Okay, so once the water is melted, the water will fall right into the aqueduct, and then the aqueduct is built so that the water could just fall with gravity. And then once the water has fell down into the hole where the water goes into the purifier will clean it because it has coffee cleaners, and then at the bottom it has carbonated rocks. And then after it's clean, it'll fall into a container at the bottom of the purifier, which will fall into the irrigation system. At the bottom, when it was connected like this, it was connected onto this, but the water, it wasn't covered up right here, right? So the water kept falling out through here. So we would just need to find a way for this to be secured and the tube full enough so that it'll just fall into the irrigation system.
So basically, it collects the water from the water filtration. It collects the water, then this collects the water that's over here. Then it pours out right here, goes down there, and goes into the greenhouse, which waters the plants.
So what it does is we put 4 D batteries because they're the same strength. But since they're D batteries, they last longer. So that way we would have to switch them out less often. So the straws here, the water will go down here, fall here. We would have a hose connected to the greenhouse and some way to heat the greenhouse, that way the plants wouldn't freeze to death.
Being able to survive on Mars, and this contributes to it by being able to dig up materials that are necessary to build on Mars, like iron and other metals that are found in the earth. And the project works by being able to spin once it's powered on, and once it spins it would be able to, once it spins it's able to dig through it. Right here it would start digging. But so there right now there's 4 different ways to power, 4 different basic power levels. This one being the weakest, and it goes higher in power up to the strongest. So this one would be stronger than the first one, being able to dig more efficiently. And depending on how you would put the wires, it would go the other way. So that's so now, since if it's digging, it would be able to go to the point where the magnet would be able to grab a piece of metal, which we don't have in there at that point, but the magnet would be able to grab a piece of metal, and then that's when it would be able to be used for other uses on Mars. And that's a brief summary of how the project works and how it would be used on Mars and in this grand scheme of the PBL.
So bottle, he fills it with hot water and then used to pump from here. And if you pump it, the air pressure will be too much and it'll shoot the cork out and go flying.
This is the recycling and this is trash, and it goes down the conveyor belt, and this spins it, and then when it spins it, it's supposed to go down the craters, and then this one, it's the compost made out of trash, and it goes to the truck, and it drives to the greenhouse over there. Okay. Tell me when
think that's enough for now.
Yeah, like because it's gonna take like more trips.
Yeah, and so so at the greenhouse, someone is supposed to get the trash out and like the compost and put it into the greenhouse, but they're still not here. So it's basically they just choose their things that they need and put it into the greenhouse so it could help the plants grow.
Now we're gonna go higher. And you see, the faster it goes, the electricity increases. So what it's doing is the propellers are spinning the motor so to generate electricity.
Olympus Mons is a shield volcano on Mars that is 642 kilometers, 374 miles in diameter. It is approximately the size of Arizona. It stands 25 kilometers, 16 miles high. Olympus Mons is so large, it was compared to the largest volcano on Earth, which is Mauna Loa, and it turns out to be 100 times bigger. And it is also the largest volcano in the solar system.
My name is Gary Kamengay with Ewing Irrigation. I've been working with Ewing for about 17 years. We're an irrigation supply. We supply sprinklers, drip, pond materials to landscapers, schools, municipalities. And it's very interesting to see what you boys have done with your creations here.
How many customers do you get like in a day?
In a day, between 20 to 75.
So, as a part of the company, what do you do?
I'm actually the store manager, and we work with school districts when they're putting in the irrigation for the sports fields. We deal with pipe that's anywhere from ½ inch up to 12 inch in diameter.
So like, how much would it cost to like supply a school like, for a field?
Every school is different. When you look at what they do currently, where they do xeriscape or desertscapes, there's a lot more drip irrigation. So there's a little more labor involved and less cost in the irrigation material. When you're looking at a ball field, there's a lot more cost because of safety on the sprinklers. So those sprinklers go 40 to 60 foot, and they don't want to have students get hurt when they land on them, so they have rubber covers.
So like, how long has like your company been open?
Ewing has been open since 1922, approaching 100 years.
So, for
example, the projects that you're doing regarding the water, how much would that be to build expensive?
If you're building it for Mars, it'd be very expensive. If you're building it for here, it would be fairly inexpensive because we have an atmosphere that would keep the water liquid. The gravity would keep the water at a certain elevation, so you're not going to have to, you're going to need a pump to pump it up to a height to generate pressure. Once you have the pressure, then you can put it through the irrigation pipe to disperse it. So Mars has a lot of challenges. And you've come up a very long way with coming up with some good ideas.
So for the piping, is there some type of pipes that can help us with keeping the or we have to add that in ourselves?
I think if you were on Mars, you'd probably have to be in an enclosed building because that's really the only way that you could keep the temperature the same. Once you get the water from ice to liquid, you'd be able to keep it in a liquid state. Because if it went back to negative 81 degrees Fahrenheit, it's ice again. So there's a lot of challenges. You'd have to have a fairly big area, like a warehouse, to filter the water, melt the ice into water, and clean it. And then it would have to be transported to the greenhouse. You'd have to do that probably through insulated pipes, unless it was in the same building. So the cost would be the structure, not so much the irrigation.
So for the job you have, what type of majors and subjects you have to take?
Actually, I grew up in the industry, so I learned with a lot of hands-on. I got an AA degree in junior college, but I haven't required a doctorate degree or anything like that. Congratulations, keep up with your learning. I'm sure you'll probably be the minds that get us to Mars.